All right. So let's see some of these. What you got?
Well, I signed into there with my OTC account, and it says I'm not eligible for a free account. Is that correct?
For that DevTools thing?
Yeah, you never signed up.
And it could be, I thought that it just automatically gave it to everybody. It could be that somebody has to do something.
But yeah, like I'm an agent account. You make an account with OTC. That might be that might be the problem. Let's just sign in or sign up.
Sign in.
I don't know why. Yeah,
I mean, I kind of think it would do the same thing as we're doing with OTC account. It should recognize. I had all sorts of trouble with my account getting it set up. They're different. Probably not. Like, so you close out of your browser and then not exactly. Still just not exactly right. Right. It's so hard to tell because it looks just exactly what.
They don't want you to sign up.
There was one guy at the help desk who got really involved in it. Yeah. We'll find him. See if he can get you switched. What about you? Did it come back? Or was it just mad at you? No, mad at you. Oh, you started it.
Yeah, I think yes, on software you like to pay a subscription.
We don't need to install it again, do you? Mm-hmm. That's a dude that tries to do that.
This.
So, will it let you run it through? Okay, so go ahead.
Wait, so we all have to like decide I was going to say, I don't think that each of these so I think it was for your class.
Oh, yeah. Okay, I see. Let's see him, let's see him. Okay, we're just gonna look at a few. We got a lot to do.
You want to show us yours one? Take over that Zoom session and let's show him. The price you pay. I'm falling over. This room's making me wobbly. Oh, look at this. It looks so nice. Let's show everybody what you got.
For mine, I didn't put it in my class, so I just did it all in the same class. And I just did as factors. Then I called them. I did call and call. Basically displays for options. And then once it's going to then ask them to basically get a choice, which they pick a number. It's going to see what number they pick, and if they didn't pick any of them, they don't get anything.
Let's see it run.
How do I get that to run on? I didn't share my actual screen, I just shared the.
Oh, do the share again and share the screen instead of just that one window. Here we go. Because they were greedy?
For me, I just did I didn't do green, I just did the main menu, unfortunately. I wasn't sure how far we should go into it. So.
I like it. What do you guys think? Good use of methods, good main menu display, good use of if statements, everything looks good. Let's see somebody else's. Someone's going to show us. I'm going to have to pick on you. Let's see. Who we got here? Mohammed, how's yours?
What?
Behind you. How's yours? He's looking at me like, you don't see me. You got one for us? Oh, okay, great. Let's see.
I don't know if this is all right, but I ended up using a switch statement for hours. So avoid that. Don't look at the left side of the screen. So it works pretty much like the other program. You enter the number and
He's touring Japan.
and invalid. If it's a number outside of 1 and 5, if it's a number outside of 1 and 5, it just says number out of bounds. So that's the end of the program. But the number in between 1 and 5, that's the reward. And I guess it's all right that you use if statements.
Mm-hmm. Yeah, that's fine. The switch case statement is fine. Okay.
And we ended up collapsing them down to just pretty much one case. So we only get one reward for this program.
And that's it. We're just out of luck. Okay, do we have any other groups? Let's see some others. Thank you. What about this second row? Somebody on here, look at them, look at each other. You. Sure, tell us about it.
All right, so I made a method out of it. I guess we made a method out of it. And then so it goes into a while loop first to check it. If it's not a number, it keeps going through the while loop until it finally gets a number. And then for the switch statement, it goes through, and if it's 1, 2, 3, or 4, 5, it'll do those, but for the default, so if it's anything above or below, it just reruns the method and makes you choose again. Calls itself. Does that make sense?
Nice. Any questions? Theirs looks pretty safe as far as it's going to catch any sort of non-numeric data that gets entered. Good job. Okay, let's get on with our stuff. Good job, you guys. I'm going to share mine. If I could get my mouse over there. And I'm going to go to Canvas. And look at lesson 8. So we do have a REPL course for it. And we have some practice assignments through this Programmer site. Here's the assignment to turn in your if statement program. It only needs to be turned in once for the group. So whoever wants to do it, that's fine. And then let's try to go to this program all thing. Now it gave us a whole bunch of trouble this morning, kind of like trying to use that DevTools site. We should be able to get some issues. But I want to click on this one that's the rectangle. I have it open, so I'm going to log out first and make sure that I'm not already logged in. Okay, so I'm going to try to go to it. And this Programmer site is actually linked to Canvas, which I think makes it a little worse as far as trying to get it to work. We'll see. I don't know if we're headed faster. So. Well, it says it's waiting down here, so I think I'm gonna click the X to stop it, and I'm just gonna go to that site, programmer.com. So programmer without the E. Now, once we set up an account, it seems to work a little bit better with Canvas. So let's try and do that. I want you to go ahead and sign up. Now, this site is totally just for you. It's just practice programs. So you can sign up using any account you want. You have to use your OTC account. Whenever we're learning the program, I know it can be really hard just to come up with ideas of programs to write. People say, give me ideas, and you know how it is when somebody says that to you, all of a sudden your mind just goes blank. But this place has all sorts of ideas. So if I want to look at C#, I have projects, challenges, examples, page after page after page after page of project suggestions. Down here, as we look at these challenges, you'll see people have voted on them as far as, you know, how challenging of projects they are and how much they enjoy completing them. So the ones that are most liked pop up to the top. Now, just because they have it sorted by language doesn't mean that you could only look at the C# ones. I mean, you could look at the Python projects and assignments and do that in C#. It wouldn't be a problem to do that. Okay, so I've already got an account created, so I'm going to log in. Is it letting you create an account? Yeah, stuck. That's what it did this morning. So I'm going to see if I can get logged in, and I will show you what it's supposed to do. Oh, you dog. I'll go through the whole process that I did this morning. Isn't that amazing? I don't know about you guys, but I think this site might need some help from some programmers. I might have to fix it up a little bit because it is in sad, sad shape. I think it's still waiting on me to use the reset. I think every time I log into this site, I have to do some sort of password reset. Okay, so I think I got logged in. I'm going to go back to Canvas and click on that link again so that you'll see what it's supposed to do. And maybe we can get there someday. If I click on the rectangle challenge, it should go straight to their site and bring up that challenge. I'm going to keep this open for us for when we are done here looking at our looping stuff to kind of take a look at this rectangle one. That's kind of a challenge for you to see if you could get that programmer site to work at home. And I do think when you get outside of the network here, you actually might have better luck with it. Okay, so we'll come back to that and look at this print rectangle project that they have. But it does not seem like it's going to let you get that account created here no matter what we do. So I'm going to go into lesson 8, into the video section, just to grab that PowerPoint, this PowerPoint right here. And there is a video. I was so sick Monday, I didn't even look to see that. I could have just said, oh, watch this awesome video. So let's just make our own. We're going to talk about looping. I'm still missing some pieces up here, so I seem kind of out of sorts, sorry. Talking is never the best anyways. But we need to talk about repetition. Repetition, a lot of times we think of that as looping or repeating statements. And repetition statements, like I said, are looping statements, and they let us control the flow of our code. We can have certain code be repeated over and over if the test condition is true. We can have code be repeated until a condition is true. Or we can have code just be repeated a certain number of times. Whatever we want to do, we can do that. Here's an assembly line for us, a circle. In this assembly line, we paint cars. And so at the beginning of the assembly line, we always are looking, is there another car to paint? If there is, we're going to tape it off, get it ready, move the car to the paint area, paint the car, then move it to the drying area, which is going to free up room for another car. So is there another car waiting to paint? If so, let's take it off, move it in, paint it, and then move to the drying area. And of course, with our assembly line, we're just going to keep repeating these steps over and over and over all day, or the entire shift, until we're done. So in this example, we're really repeating many, many activities, but it's kind of an example of a top controlled loop. Before we do anything, we check to see if there's another car, right? If we ran out of cars to paint, we wouldn't execute our loop anymore. So that's controlling our loop. Whenever we're doing basic looping structures like that in C#, we can use the while statement. And the while statement is exactly the same as an if statement, except that it uses the keyword while instead of the keyword if. Everything else about it is exactly the same. Our conditional expression is exactly the same as with an if statement. But that while keyword changes the meaning of everything to say, look at this expression, while it's true, keep repeating all of these steps in this while loop body. Just like if statements, we can leave off our opening and closing curly braces if we only have one line of code. We can put it all on one line if we want to. So our condition, when we're looking at a while statement, then our condition is exactly the same as an if statement. It's basically an if condition that is either going to be resolved to be true or false. And again, remember, we don't have any other options. That's it. Just like an if statement, our relational operators are less than or equal to, greater than or equal to, is equal to, and is not equal to. So our test condition, just like an if statement, has to have a left and right operand. We can use variables. We can use all sorts of literal values in our condition, however we want to set that up. In this, in this flow chart, we are looking at kind of sitting at a red stoplight. So our stoplight here could be considered a state variable. It's the state of the stoplight. So whenever I start up this process here, I'm checking the light, and then I'm sitting at a light. Is the stoplight red? If so, continue to stop, and then check the light again. Is the stoplight red? If so, continue to stop, check the light again. We do that, don't we? Sometimes we get distracted and get mad at those people that got distracted and are on their phone because they didn't notice that the light isn't red anymore. But this state is something that we're used to constantly monitoring. So we're keeping track of that looping mechanism ourselves. Once that stoplight is not red anymore, we're going to stop stopping, right? We'll go ahead and go. So whenever we have any sort of situation like that, we call that a state, the state of the stoplight. We can simulate some code like that while our stoplight is red. Our order of operations, bless you, still applies. Bless you, what happened? It's going to go across there now. See what everybody gets to sound like. Again, our order of operations controls are conditional just the same as it does in an if statement. Anytime we have a looping construct, then, we have three main things or phases that need to be taken care of. First of all, we have to initialize variables to begin our loop. In our example, we checked our stoplight to see what color it is, part of our initialization. Then we have to test. We have to conduct some sort of test to see if our condition is valid. In our case, we check to see if the stoplight is red. And then within our loop body, we have to do updating. So somehow we have to make that stoplight change from red to green, or notice that it has. We'll come back to those in just a minute. Those are important. Our loop control variables have to keep all that looping going on. Now, sometimes we might have inequality conditions with our relational operators, and we might want to keep repeating some process while we have an unequal condition. So, for example, let's say I have a display that I've created and it's too big to fit in the window. I could have a loop that reduces the size of that display by 10 pixels every iteration until it finally gets to be small enough to fit within the display. Or I could have a loop maybe that checks to see if the user has input 10 names. If they haven't, I would continue and keep prompting until we get 10 names. Another example would be like at a fair, say we have like some tickets, and we would know that if we still had tickets, or if we still have 5 tickets, we could ride another ride. So sometimes we're checking for unequal conditions. Okay, so while loop summarized. While is our keyword. Opening and closing curly braces delineate our loop body. And there is no semicolon. So if you look at that while condition, we will have semicolons on the statements in our loop body, but we won't have a semicolon on the while statement itself. So more on the top controlled loop. Whenever we're talking about a top control loop like that, the test condition is always at the beginning of our loop process. We execute the loop body if our condition is true. So let's see here. We have a condition of checking to see if I have chips. If I do, I'll pick one up, add some dip, eat that chip, check for another. Do I have them? Pick one up. And so I can keep doing this looping mechanism. But my test condition, remember, is controlling whether or not I do each iteration of my loop. So let's see some things that are similar to that, like a top controlled loop. Look both ways before crossing the street. Don't count your chickens before they hatch. All of those things are things that we would do before we went off to do something else. What about bottom controlled then? That's a little different, but for our chip, might not look too different. We might have to actually see some code. If I have a bottom controlled loop, I start out picking up a chip, and then I add some dip, eat that chip, then I check for another, and if there are more chips, I'll go ahead and execute my loop again. So notice how in this bottom controlled loop, I'm going to eat at least one chip, or try to, before I give up. And in the top controlled, I didn't. If we were out of chips, I didn't get any. Now, some things that are similar to a bottom controlled loop. There is always at least one. Jump right in. Don't judge a book by its cover, and try before you buy. So all of those things give us an option with a bottom controlled loop. So a bottom controlled loop in C# uses a special syntax. And if you use Python in your 120 class, we didn't have a similar option in Python. This looping structure can actually be very efficient. We start with the keyword do, and after the keyword do, we have our opening and closing curly braces with our loop body inside of them. Then after our closing curly brace, we put our while keyword with our condition. And at the very end, we close it with a semicolon. So it's way different syntax than the other while loop, the do while loop. Now, because the do while loop is kind of upside down, there is no option to run it without opening, closing curly braces. It doesn't have this, a one-line option, because the while statement has to come at the closing curly brace, so it keeps us on track. So here's a count-controlled loop. Let's open up Visual Studio and see if we can create it. We'll try. We didn't get to do as much practice with our if statements. So do let me know if that's something you'd like to look at offline, and we can do that. I'm going to create a new project. And whenever we go to our new project, you guys all probably saw this Monday, there are lots of things that we had to pick all over again when we moved to a new computer. So sometimes we can make the wrong choices because we don't normally have to make these choices. Usually it's kind of saved. We want to do a console app, and we wanted to do the .NET framework. That's the one that's giving us the least amount of trouble. Then we want to make sure where our project is getting saved. I've always been saving mine to the C drive, and so last week before we moved, I made a backup of that from that computer over there. You are probably saving yours to your OneDrive, which I think is the right place. Do that and get them all saved. Now, for this particular application, let's change our solution name. I'm going to make it L8 looping practice. And then let's change the name of this first project. This very first one that we're going to create is going to be a count-controlled loop, kind of a basic one. Now, if that all looks okay, I'm going to click OK. Let me know if you're having trouble, if it's giving you a hard time, so we can get you fixed. Okay, so in my count-controlled loop, I just want to create a couple variables that are going to be integers. So I'm going to create those within my main method, and I want an integer named count, and I'm going to start it with a value of 5, and I want an integer named iteration, and I'm going to start it with a value of 0. So if I look at these two, count is kind of going to be my loop control variable, right? I'm going to execute this loop until my iteration gets to that number. And then my iteration variable could be thought of as my iterator. This is the one that changes. So it changes value as the loop is executed. So let's put our while loop in. Our condition is that while our iteration is less than our count, we want to execute our loop body. So for every time we execute our loop body, let's write out a message that says this is iteration number. And then our iteration value. And we have, I'm going to put this in. From the very beginning of the semester, I've been forcing you to type those zeros and ones, the parameters, and then the parameter replacement value. They actually fixed that in C# a release or so ago. You have to know how to do it that old way because it's been that way for years and years. But we're going to switch now to doing it the new way. And the new way, right before my opening double quote, I'm going to put a $sign. And that tells C# that this is an interpolated string, which means I have a parameter here with a variable name in it. And I just want you to replace that parameter with that variable. So much easier than doing 0, iteration. Save difference. Now I want to save this and I want to run it. I'm going to do Control F5 because I want to see that console. Now, my iteration number is never changing, which should be a hint as to what's going on here. If you watch this, if I can find it, where did you go? You should see an infinite loop. And infinite loops are bad. We don't like those. So I want to stop that. You can't really tell much with the way it's set up. And I want to make it not be an infinite loop. So to fix that, I need to increment my iteration number. So if I don't, I'm just going to have an infinite loop. My while condition is never going to be met. I'm going to keep executing that thing forever. Now, if we have that fixed, let's try it. We should see this is iteration number 0, 1, 2, 3, and 4. Does everybody's look okay? Got it? Just a little baby loop. Now, as we look at this, our while condition here includes our test condition and this statement that adds to the iteration variable updates the iterator to make that loop end, right? So I said we have 3 stages to a loop: initialization, test, and update. So we've got all of those steps in this little loop. It's working for us. Let's add another one. I wanted another while loop right after this while loop. And I want to do the same exact thing. While iteration less than counts. I want to write out my line. I'll put my $sign in front of it and say second loop iteration number. And then I'll use iteration as the variable to print. I know I need to update, so I'll put that in. So when I run this on, I should get, this is iteration number 0, 1, 2, 3, 4, and then I should get second loop iteration number 0, 1, 2, 3, 4. Let's run it and see. We're not getting our second loop output. Why is that? Iteration's already too high, exactly. So we need to initialize again. Set iteration equal to 0. So anytime we're going to do a looping construct like that, we have to make sure we reinitialize. And for this program, it's kind of easy because we have it all together, but sometimes we can have things pretty far apart, scattered around. So it's best for us to always be aware of that. We should see both loop outputs now. Yay. Okay, I want to create another project so that, again, you can just look at this solution and get all of the different loop examples. So right-click on your solution and choose Add New Project. And this one is going to be a do while. kind of our backwards loop. Let's start out with those same variables. Count equal to 5 and iterate equal to 0. And we're going to start out with this do keyword. And I'll just go ahead and type the opening curly brace so that Visual Studio gives me the closing. Now within the body, I'm going to do a console.writeLine. We'll say this is iteration number iterate. I noticed that in the previous program, my variable name turned black. That Visual Studio was able to tell that was a variable. And this one is not. Is there something that I'm missing? Dollar sign. Can't trick you. Perfect. And then that we can see it turn black and acknowledge it. Now I do need to increment iterate. We'll bump it up. And then our last thing, if you notice, we still have a squiggly red line after our closing curly brace because it says something is expected. Now it gives us a whole bunch of options. It's like, I'm not exactly sure, but something is expected here. Well, we know we need a while statement. And our while statement has to include our condition. So we're going to say while our iterate is less than our count, semicolon. Now, if that looks good, try running it. And we should see again, this is iteration 0, 1, 2, 3, 4. So this loop, in effect, for what we've done is pretty much the same as a while loop. Let's try it. Oop, I need to update which project is running. I want my do while. Control F5. And I see here are my iteration numbers. Now, how could we change this do while loop so that you could see I can change my count to 0. So we shouldn't, if we had just a regular while loop, we wouldn't execute it at all, right? But since this one is top controlled, even with our count set to 0, we will still see one line output because our do while loop always executes at least one time. Make sense? Now, sometimes people don't like using a do while loop, and other semesters I see people really implement them well. It's kind of like working for a company. Sometimes you might work for a company where they don't like doing things a certain way. And you might go right down the road and find a company that loves doing things that way and think, why are we not doing it that way? That's just how it is. And the biggie, our for loop. So the for loop gives us the ability to combine all that stuff into one piece of syntax, right? So when we're looking at a for loop, we actually have 3 parts to the for loop. The first part is the initialization section. The second part is our test condition. And the third part is our update of our looping variable, our iterator. So in a for loop, I can do all of those things at once without having to have all those separate lines of code. So in this example, we set up a variable to hold our count. But then we created our iteration variable as part of this for loop. We say, oh, I want to declare an integer. Its name is iteration, and I want to start with the value of 0. Our test condition says this for loop should be executed while iteration is less than count. And then our update section says every time this loop is executed, you should update the iteration variable. Let's create this one. In Visual Studio, again, I would like to have a new project. And this is going to be a for loop. So for our example, we're going to start with our count variable again, but then we'll use our for loop. And all of these pieces are things that we did in our previous loops, just kind of in different places. So the for loop kind of brings them all together, making it a little bit easier to handle. So I want to do a console.writeLine and output for loop iteration number. So every time my for loop body executes, I should have this message output. Uh-huh. Yeah.
What do we do if you want to go above 1, like instead of the iteration plus plus?
Do what?
How do you type it if you want to go by, like, say 2s instead of iteration plus plus?
Maybe what I have to do iteration plus 2. You really, whenever you're working with a for loop, you're limited on what you can do for your iterator. So you can do some things. Let's look at the.
It's plus equals 2, right?
Do what?
It was plus equals 2, right?
Plus equal to, let me change it like that so everybody can see. Because that's a really good hint. And also, we could have minus equal if we wanted it to go, to decrement. I'll run it like that and see our plus 2 thing. Make sure my for loop project is the one that's going to run as my startup. And then since we did 2, I've just got 0, 2, and 4. So very cool. Now my iteration variable was declared in my for loop. So that means it's local to my for loop. So that means I can't get to it anymore outside of my for loop, right? Because it is local. So when I look at my variable count, my count variable is local to my main method. I wouldn't be able to address it outside of that main method. My iteration variable, since I use the int keyword up here, is local only to my for loop. So if I need to know what that value is after my for loop is completed, I need to allocate that variable myself. So I could go ahead and say I have an integer iteration that I'm going to stick at 0, and then I can get rid of the int keyword here. And then I'm using an existing integer variable to control this for loop. So I could totally do that. I don't have to have an integer that was just created for the for loop.
So you can set the variable integer for whatever you want for each for loop.
Yeah. So if we wanted to start at 150 weekdays, and
a lot of times people don't realize that they can declare these variables outside of that for loop and keep the values if you want to. You know, we do that int I equals whatever.
You don't even really need to count variable there at all. You could just say 5 for iteration less than 5.
Right, and what kind of things would that be doing if I did that? Tell me. Anytime that I have a literal value in my code, that's a problem. So I never want like a number 5 like this. I want it defined at the top. And I can tell you one really important reason is so that future developers coming in can identify exactly what that 5 is. Because if they see it as a variable, they're like, oh, this 5 is how many times we want to execute this loop. And my management came to me and said, we want to change every time we execute a loop to 50 times. Then I would just be able to change it one place in my code. If I had to change every place, I would have to analyze every single place to make sure that this were one that needed to be changed. And then I would have to update it and test it.
Is that just programming?
That's just programming etiquette, yes. And that's, a lot of that is from Y2K. If you guys have ever heard of that, where when they switched from the 20th century to the 21st century, a lot of developers over time had only used a 2-digit century. And instead of putting 19 up here in a variable somewhere that's an old century and then using that variable in all of their if statements, they had code, just spaghetti code everywhere that said, if the current year is less than 19 and this is greater than that and this is greater. Some companies wanted to not worry about it until 1985. A lot of people made a lot of money because that code was that way. If every programmer had created variables at the top of their program and said, century, last century, this century, it would have just taken a few seconds to change. We still don't have that. We're still not to that point. But that's why we don't like to have any sort of literal value declared within a for loop. We'll do the zeros. We're used to zeros. Not a problem.
So it's just a common convention, but it's not an end of the world type thing by any means. Okay, so we see that if we want to keep our loop control variable for a for loop, we need to declare it beforehand. What else? Nesting. Oh, let's make one more project here. For this one, we'll call it nested loop. We have a row and column kind of arrangement. So I'm going to do my outer loop, starting with a for statement, and I'm going to control it with an integer named row, and I want to initialize row to 0. I want to output 5 rows, so I'll put that as my condition and add to my row number. Now I'm going to use a console.write because I don't want it to go automatically to a new line. I only want to go to a new line when we have a new row. So in our for loop for our row, we'll output a new line and then our row number. Again, I need to put that $sign in there. Let's create that variable. I'll call it width. Let's say width is equal to 5, and I'm going to change my condition. Oops, I need to make that an integer, don't I? And I'm going to change my condition here. Instead of using that hard-coded number 5, because I was just saying that's a bad practice, I'm going to use my width variable instead. I want to run this then and make sure that I get 5 rows of output. I'm still only getting 3, so I must need to make this be my startup project. And here we go. We output the word row and then our row number for each row. So I have row 0, 1, 2, 3, and 4. Everybody okay? 4 awesome rows. So let's put a for loop within that one. I'm going to go ahead and comment this end of row 4. And I'm going to add a new for loop. My inner for loop is going to use an integer named column or call. And again, I'm going to start that at 0. Run while it's less than 5, and I'll fix that. And then I'll add to my column variable. So for each column across this row, I want to write a little bit more output. I'm going to do a space and then the word call and our column variable. Now I'm going to call our column height. Of course, it's all relative and it kind of depends on your point of view, but I'll use this height variable. So super easy for us to change our code from using a literal value that we have typed in to using a variable. Sometimes that can be tricky when you're first getting started. Okay, let's run it. I'm going to control F5. And now this is what you should see. For each row, we have 1, 2, 3, 4, 5 columns. So we kind of are creating our own little grid here. So that's the end of our for loop for our column. The last couple of things here, finish up. Our logical operators are just the same as our if statements when we're building our condition for a while loop or a for loop. And in summary, the important things for us. Repeating code is really important and allows us to set up an algorithm and execute it over and over until a condition is true or a state is changed. And of course, decision making is really the heart of it, because if we haven't figured out how to make our decisions, we don't know how to control our looping structures. Our repetition structures for C# are while, do while, and the for loop. I'm going to try some different practice programs. If everybody's got this one, we should be able to make the rectangle. I'm going to bring it up because I know it wasn't letting you. Okay, take a look at this one. Write a program which takes input length and width of a rectangle is integer and print the rectangle. I don't want to go to all the trouble of prompting the user for input. So let's create a new project in here. One more. And let's call it rectangle. So what do we need there? Do I? We need some nested for loops. Length, they're talking about going across, right? Or up and down. Can you tell? Which do they mean? So length you think is height, the number of rows? Because that one is kind of confusing to me the way they have it. Okay, so let's do that. We know, first of all, that we're going to have an integer for our length of 10. And then if I think about the way the system works, which would need to be my outer for loop? Would it need to be the one that's going up and down? Or would it need to be the one that's going across? Up and down, right? Because we know we can't make that console go any other direction. It's too dumb for us. So that would be our first one. Let's put it in. Let's see. So we're going to be going up and down. So this is going to be columns. Now, for this for loop, I'm going to output console.write, and I just want to output a star. Control Z, because I got extra stuff. Somewhere we got to go to a new line, though. That's probably something that'll happen in our row logic, huh? When we get to the end of the row. I'm going to run it. Control F5. So even though I'm just doing writes and I've never gone to a new line, I am getting my stars going across. I would like them to go up and down, but that's a problem that'll get taken care of as I add more information. So let's add our inner for loop. We want to execute while our row is less than what? Our width. I'm going to go ahead and put in a console.write of that star character. And then the key here is that after our inner for loop gets done, each time we want to output a new line. So we would do a row and then do the columns across it. And then when we're done with the columns across it, we're ready to move down to do our next row. So let's see what kind of output that gives us. Give us some debugging to do. Interesting. So it's really pretty right, isn't it? We have 5 stars across and I think 10 up and down. I'm not going to count them. There might be 11. We might have to fix that a little bit. But how come it's not empty? My box is full. I'm going to let you fix that. So we have our rectangle good. Everything's coming out right. But the program our site wants us to not have any stars in the inside of it. Can you fix that? So I want you to think about that before next time, and we'll fix it together or look at all the awesome people who have got it. So for next time, you're going to try to get an account set up on that program or site, hopefully at home. Maybe it will work. If it won't, I'll talk to the help desk and figure out what the deal is. It's almost like it's blocked or something in here. Figure out the rectangle, see if you can get it to work. And then you have a REPL. Let's take a look at it before you start working on it. Doo-doo-doo. So in our REPL, there are 17. A lot of them are super, super short. Some of them might make you crazy. If one of them is making you crazy, skip it. There are lots of other ones. Okay? Skip it, come back to it. Rebel's gonna let you skip it, it doesn't matter. Come back to it later and see if it makes more sense at that point after you've looked at it. Don't forget you can email me if you've got some sort of problem that's making you crazy. Now, some of the things that are in here, sentinel controlled loop, that's a thing that you might not remember. A sentinel controlled loop is one of those kind of loops where we say, please enter the name, enter -99 to exit. -99 would be our sentinel value. So that's what kind of loop that one is. So you should have an option to do a lot of exploring. So these should all be quick, just like the examples that we did. But when you're looping, it really can be an intense brain exercise. We can use Visual Studio if you're wanting to explore the debugger and get in there and use that. That's a great thing to use with this kind of stuff. The other thing is each of these, or a lot of these, have a video. Let me know if it's like super bad. I might not be able to do anything about it, but I can try. A lot of the videos are just like other things where you have technical difficulties, and I don't know if you've heard me complain about it, but audio systems don't like my voice. My voice is weird, and the sampling rate just doesn't pick up a lot of my voice, so sometimes there's just like little weird glitches. And also I have trouble with my webcam, and I think I've got it all straightened out. So let me know if any of those videos are so bad that they need to be redone. Hopefully you don't need them, and you'll just go through it on your own and not use the videos at all. So the videos are designed to be last ditch effort. You don't know what to do. You've got to have some help, which is fine. Okay, questions before we start with our lab? Good, good, good. All right, lots of looping that we've seen there. I'm gonna leave you with it. Let me know if I can help with anything. And you're on your own.